Hello, in this video I'm going to add the option to input collision geometry that can interact with the pile simulation. Now the second thing I want to add is an input for a collision geometry that we might want our simulation to interact with. So let's add a box here, and this will be our collision object. Let's add a null and call this input collision. So this will be a second input on our digital asset. And we've already got some collision geometry here. We've got our container. Let's add a merge and attach our input collision to this merge. Now we've got these two objects merged. We take a look at our bullet solver and rerun the simulation. We can now see that it's interacting with that object. Now one thing I want to do is always ensure that our geometry is positioned above any collision geometry. So if we move this grid down slightly, and now it's intersecting with our collision object, and we rerun the simulation, we can see it's currently intersecting with that collision object, so it's not going to work correctly. So what I'm going to do is move this down, and after our copy to points, let's add a match size. And let's attach that to our box. Now I don't want to justify on the X or the Y, so let's set that to none. And then for justify Y, let's set this to min. So this has centered our objects so they're sat on the grid. I want to move it up slightly. I always want it to be slightly above the floor, so it has some kind of way to fall. Let's say 0.2. And then I also want it to be positioned above our collision geometry as well. So to do that, what I can do is on the match size, is come up to this little cog and select add spare input. That's added this field here for this spare input. And what I can do is click and drag this null into that spare input. Now you can see here we've got that reference to that null. You can also see we've got some additional lines appear here as well. So we've got two different lines. We've got a kind of a brown line here and then this purple dashed line. If you don't see these, come up to View, and under Dependency Links, you can select Show for Selected Nodes, as well as check Show Dependency Links for spare inputs. So this purple line shows that there is a reference to a spare input on our match size, and the brown one shows that there is a dependency link between these two objects. With this spare input, I can use this with an expression on our match size. What I'm going to do is use that bounding box expression that I used previously, and the expression I want to use is plus bounding box, open brackets, and this time rather than typing 0, which referred to the first input on our spare input, I'm going to type -1. And then the type I want to use here is d_y max. So that's the max position of the bounding box on our collision geometry that's on our spare input. So -1 refers to the first spare input. So whereas 0, 1, 2, and 3, and so on might refer to the inputs here, -1 would refer to the first spare input, -2 would refer to the second, and so on. This is a neat way of being able to link objects together and to reference them. And now you can see we have our geometry positioned above our collision geometry, plus an additional 0.2 units. So now if we run our simulation, it's no longer intersecting with the collision object. Now, as you might notice, as I make changes, I need to always come back and click Reset Simulation to update it. I don't want the user to always have to do this. So what we can do is, under Setup tab, come down and uncheck Cache Memory. So now the simulation will no longer cache the simulation, and whenever there is a change to the inputs, the simulation will be automatically reran and updated. And one final thing I want to add to our tool, we look at this third model here. Rather than being centered at the origin, it's actually sat on top of the grid. So when this is copied to points, it won't be copied to the center of a point. Let's connect this. In fact, let's just connect this straight to the input, and let's just return down this density to say 1. And let's look at these points and template this geometry. There you can see we've got our point there below our geometry. Obviously we don't want that. So what I want to do is, after our switch, let's give us some more space, is use a for each loop. And we want a for each connected piece. I've created this connectivity node, and we don't actually need this because we're already specifying a piece attribute here, either using a connectivity node or the user is defining a piece attribute. So let's delete this connectivity node, and we just need to update this for each end with our custom piece attribute, which is underscore pile underscore name. And this will now run over every piece of geometry, and we're going to add a match size. And we can leave the values as default on this one. And this will simply center every single piece of piece of geometry so that it's at the center. So when it's copied to points, it will be positioned correctly. We just need to connect this copy to points to that for each. And there we go. They've updated and they're now centered on each point. So we're now ready to turn this into a digital asset.